nanometer chips. China says yes. For years we were told a story of a technological wall built brick by brick with patents, sanctions, and billion-dollar machines. The most critical component of that wall, the 3-nanometer chip. A holy grail of speed and efficiency that was, for one nation, said to be completely out of reach. But what if the story we were told was a lie? What if, behind closed doors, a new chapter was being written? A chapter where the words impossible and can't were simply rephrased. What if the very tools used to build that wall that were just a suggestion? This is a story of a quiet revolution. A revolution that has, in a single, unannounced move, shattered the global balance of power. The technological gap you thought existed has just been closed. The unthinkable achievement. For decades, the global semiconductor industry has been dominated by a select few. Companies like Samsung and TSMC, armed with multi-billion-dollar extreme ultraviolet EUV lithography machines from ASML, have been the gatekeepers to the most advanced chip nodes. These machines, the size of a bus and filled with highly sensitive optics, became the ultimate symbol of technological superiority. The story was simple. If you don't have EUV, you don't have advanced chips. Period. Then came the sanctions. A high-fence, small-yard approach designed to cut off China's access to the critical technology, ostensibly to slow their progress in AI, 5G, and other key areas. It was a strategy based on a verifiable fact. Without EUV, advanced mass production seemed impossible. But what if the entire premise of that strategy was flawed? What if the dependence on EUV was never an absolute but a choice? Choice of convenience? This is where the story gets interesting, because the narrative we were all sold is now being rewritten by one of the most resilient companies on the planet. Huawei, a company that since 2019 has been at the epicenter of the tech Cold War, was supposed to wither. Cut off from Google's services, reliant on its own Harmony OS and starved of top-tier chip access, many predicted its slow decline. But that's not what happened. Instead, it became a catalyst for a national surge in innovation, a symbol of defiance. It became the digital dragon. Now, rumors are swirling that something truly unprecedented has occurred. That Chinese companies have, with almost zero fanfare, achieved a leap in semiconductor technology that few believed possible. But these aren't just rumors anymore. The evidence is mounting. Before we dive deeper into the technical marvel, I want to ask you to do one thing. If you're a fan of seeing the truth behind the headlines, if you love seeing how a global challenge can spark a revolution, hit that like button. Share this video with someone who needs to hear this story. And of course, if you're not already part of the Revo Now community, make sure you subscribe and turn on notifications so you don't miss our next deep dive. This is a story you'll want to be a part of, the DUV puzzle and SMIC's role. To understand this breakthrough, we first have to revisit the fundamentals. For years, the industry relied on deep ultraviolet DUV lithography. These machines, while less advanced than EUV, were the workhorses of the semiconductor world. To create smaller chips with DUV, manufacturers had to use a complex and laborious process known as multi-patterning. It's like using multiple stencils to paint a single intricate design. It's slow, inefficient, and prone to error. This is where the story of SMIC, a key player in this narrative, becomes crucial. SMIC was already a world leader in producing chips up to the 7-nanometer node, using a highly advanced form of DUV multi-patterning. This was a testament to their engineering prowess, but it was widely believed to be the ceiling. To go beyond 7-nanometer to 5-nanometer or even 3-nanometer was seen as economically unviable and technically a dead end with DUV. The cost and complexity would be astronomical. The yields, abysmal. But what if that wasn't the full picture? What if there was a way to make DUV perform at a level it was never intended to? What if the constraints of multi-patterning were not a bug, but a feature? A challenge that, when solved, unlocked a completely new manufacturing path? This is where the intrigue truly begins. Because while the rest of the world focused on the high-cost, high-tech EUV, a different game was being played. A game of ingenuity, patience, and a national will to succeed. The Kirin 9000S, and the Digital Dragon's first roar. The first hint of this coming shift wasn't a press release or a leaked memo. It was a physical object, the Kirin 9000S chip inside Huawei's Mate 60 Pro. This chip, manufactured by SMIC, was a marvel. It was a 7-nanometer class chip, a node that was supposed to be impossible for SMIC to produce in volume. The world's tech analysts scrambled. They tore the phone apart, decapped the chip, and marveled at the impossible. This wasn't a one-off prototype. This was mass production. This was a statement. The Digital Dragon was no longer a myth. It was real. But even with that achievement, the consensus was clear. 7 nanometer was one thing. A multi-patent 3 nanometer chip. That was a different league entirely. It was a leap that would require a new manufacturing process, a completely new approach to lithography, and a level of capital and expertise that was considered unattainable for a company under sanctions. The official line from the West was that China was stuck. That, while they had proven they could produce 7 nanometer chips, the gap to the next generation nodes remained an uncrossable chasm. That the chip war 2025 was still a one-sided affair. That China could say no to sanctions, but couldn't say yes to a 3 nanometer chip. But as the days went by, whispers turned to murmurs. Murmurs turned to reports. And the reports revealed something truly groundbreaking. The big reveal. We've followed the story of sanctions. We've seen the impossible breakthrough of the 7 nanometer Kirin 9000S. We've watched as the world debated whether the DUV path was a dead end. Now, the final piece of the puzzle is here. Multiple reports from supply chain sources and industry analysts are confirming it. The once impossible has become a fact. Huawei, in collaboration with SMIC, has mass-produced its first fully functional 3 nanometer chip. This wasn't done with EUV. This was a triumph of DUV multi-patterning, combined with revolutionary new material science and design methodologies that are redefining what a chip node can be. While the world focused on the EUV wall, China built its own path around it, brick by painstaking brick. This isn't just a 3 nanometer chip, it's a declaration of technological sovereignty. It's the moment China said yes to a future on its own terms. What's next for the digital dragon? This breakthrough changes everything. It fundamentally alters the tech Cold War. The sanctions, once seen as a powerful tool to cripple China's technological ascent, have now been proven to be, at best, a temporary roadblock. This monumental achievement by Huawei and SMIC is a wake-up call to the world. The race for 6G's supremacy just got a lot more interesting. The competition between Chinese tech companies like Xiaomi, Oppo and OnePlus and their Western counterparts is about to heat up even more as they gain access to a domestic supply of cutting-edge processors. With Harmony OS continuing to grow in power and influence, China's tech ecosystem is now more self-sufficient than ever before. This is a new era. An era of rapid innovation, fierce competition and technological independence. I want to know what you think. Were you surprised by this reveal? How do you think this will change the global tech landscape? What other technological advancements are you curious about? Let me know in the comments below, and your idea might just be the topic of our next video. Thanks for watching. This is Revo Now decoding tomorrow's tech today.
Subscribe to Revo Now and join our vibrant community of forward thinkers, change makers, and revolutionaries.